Good afternoon. I'm Pim van Stam from the Netherlands, by the way. I want to say hello for the remote viewers. There's the camera. Especially people from the NL-NOC. Maybe there are some people watching over here. If you have questions, please ask on the channel, and maybe Kitty will send it on the mic over here. My talk is about BGP updates with RabbitMQ. It's a project we're using, and maybe we can share some knowledge. And I want to know from you guys if there's something worth more developing on and have more resources on to see if it's something you can use as well. Well, my name is Pim van Stam. This is my tag from the RIPE. I think most of you people don't know who I am, but I'm in the IT industry from 1990, so it's a bit some long time. I'm working for the NB-IP since 2002, so in the internet industry. And the NB-IP is a foundation with a service organization for the internet service providers, founded in the Netherlands for the Dutch ISPs. And we started in 2014 with a DDoS scrubbing center called the NAWAS. And within the NAWAS, we are using BGP, of course, to connect our members, our customers, to our service, and use BGP to get the internet traffic. And from this is where the experience for this talk is from. This is also an operator group. So who's using BGP itself? Here? Melchior, of course. Not everybody. Well, I think you know what BGP is about. So I don't need to explain, I guess. And who's using ExaBGP? Nobody? Yes? You do. Small corner case. Well, this is a small corner case. You will see it at the end. So, but do you know what ExaBGP is? No? Well, ExaBGP is just a BGP implementation on a server, just on a simple hardware thing, simple OS. We use it on Ubuntu, for instance. And you can use BGP sessions with your router, for instance. And ExaBGP has a very simple interface. Everything that you put into the ExaBGP is sent to the BGP, and everything that's coming from the BGP session is put to your script. So you connect a script to the ExaBGP, and what the script is doing, the input and the output, is from and to the BGP session. So it's very useful for scripting your BGP environment. That's what the ExaBGP is doing. Well, and we use RabbitMQ for messaging system. And who is aware of RabbitMQ? There. Well, several people. Okay, great. And so it's a messaging environment where you have a publishing and subscription idea. Something is publishing something on the message bus, and you can subscribe to channels to get information from this bus. And I will show you later on. Well, and we use the BGP updates from our member session for several tasks. When we get a BGP announcement from one of our members, most of the times it means they're under attack. So there must be, we must do something with it. If a customer is under attack, they do not call, they advertise the BGP prefix, we get a trigger, there's something going on, we go analyze what's going on and see if the mitigation is working. So the BGP advertisements from our customers are very important for us. What we also do based on this information is the flow data we have from our environment. We send the specific flows from this destination IP to our customers. So they know what's going on for their prefix in our network. So because they can see if the attack is still going on or stopped, what the attack is like. And we do the analysis and the splitting of this data based on the advertisement of the BGP session. And from time to time, multiple customers can advertise the same prefix. So we know based on this information where to send this flow data to. Well, what we want to achieve with this BGP updates we receive is to send it to multiple scripts to do something. Filtering, sending flow information, get it into alerts to our NOC team. And what we also want, we have a pretty big environment, I guess, to have it to be scalable. And we had some idea in 2014 with the universities and academic world on some DDoS pattern recognition project, where we want to try to see if we can classify DDoS attacks and have a pattern recognition. And for this project, we came up with a message bus structure with these components in this bus to have this project going on. It's still developing, this project, and we send data on the bus, we receive data, some students are working on it, and this will be a project that takes time, it takes years. This is not our core infrastructure. It's something we have in our infrastructure for the university people to work on. But based on this bus, we also use this BGP update mechanism. So the BGP updates are sent to the same bus. So why think of something new while you have something already in your infrastructure? That's why the whole idea of this RabbitMQ thing came from. Well, these are the components we use for this EXA BGP and RabbitMQ updates. We use Juniper routers. With EXA BGP we talked about. I'm using Python a lot for scripting, etc. RabbitMQ, and we've defined some messages we want to send on the bus so that the scripts can interact with this. Well, these are the examples what we can use with this information. And this is how it is in our infrastructure. They're at number 1 here, some message types that are available. They're a bit different now with the BGP update. It's a generic message. And the other ones are from the DDoS pattern recognition project. And then I came up for this talk and some other purposes. Well, how many messages do you get per second if there are DDoS attacks going on? Say something. Well, I don't think it's about messages per second. Hopefully it's a few messages per day. So that's not very useful to do some statistics on or whatever. So what I think of was, hey, but if I get the BGP messages from my members, can I do this also for the public BGP updates? That's way more interesting. What's going on the internet? How many messages will pass through our routers? What does the full table look like? What can you do with this? So I set up a second instance with receiving the full update, the full table and updates on it. And then you can do some graphing, some tooling, visualization tools, examinations, some research, whatever. Now what can you do then with the full table updates? That's something we can do here, the statistical info, what's going on the internet, how is the updates propagating to the internet. And what we also can do with full table updates is send them to people that don't have a BGP full table. For the academic world, for instance, who don't have a BGP connection or AS number. So we can forward the information from the RabbitMQ for other things on your own network or for the other parties. And in general question, and I come to it to the end, maybe you can comment on this. How could you think of any purpose of using this? Oh, something went wrong. We use for visualization for this tool Elasticsearch and Kibana. Who's using this? Kibana? No one else? Kibana? What else do you use? Shout. What else? For visualization, network traffic? Grafana, of course. I knew. So we use Grafana as well. And these are the BGP updates. They're coming from the ExaBGP. I will show in the picture how it works. And it's going into RabbitMQ. From the RabbitMQ, there's a connection to the Elasticsearch. And with Elasticsearch, you can visualize, of course, with Kibana. But there's also a plugin from Grafana to Elasticsearch to visualize with Grafana what's going on the internet. And then there's a perspective thing. Here you can see on this one, it's about 5,000 updates per 10 minutes. Well, it's about on the internet it's pretty steady the whole day long. The number of updates on the internet, about 20, 30 updates per second. And there's also here you can see the blue ones. The blue ones here at the bottom are the withdrawals, and the green ones are the announcements. So way more announcements than withdrawals. This is for us very interesting because we have a lot of issues with withdrawals on the internet with more specifics. We have convergence problems. So we can analyze with this kind of tools how much does this happen on the internet to begin with. And these withdrawals, are these for more specifics, or is it just a withdrawal from the same specific from another advertisement? These kind of analysis are interesting for us. Well, with this kind of integration, you can use the tool you like to use. If you're experiencing Grafana, use Grafana. If you're experiencing Kibana, use Kibana. And is there some other tool people are using for visualization? No one? This is it? You don't visualize your network? Well, we used to do it with the RD graphs. And now we are migrating our RD graphs to Grafana. Well, this is the whole idea of the integration that we have. There's a very small part for the MQBGP, but it's very essential for what we are doing. The connection of the BGP updates into our infrastructure for monitoring and analysis. I wanted to have a demo or something live, but it's not possible here in this infrastructure. So I forgot to mention where it is, the MQBGP, and it's on the GitHub. So if you look at MQBGP on the GitHub, you will find the source code for this. It's a library, just about 300 lines of code, nothing special. If you want to use it for publishing messages, you need just about 4 lines of code to do it. if you want to receive the messages, it's about 3 or 4 lines of code, and then you can use it. So it's very easy to implement, and then you can do all kind of things with it, and integrate it with the RabbitMQ, with Elasticsearch, all kind of tools. We are also using now a Jabber environment for sending alerts to the mobile phone. And we need to be alerted if there's a BGP session announcement, what I told you before. And other things are sent to the same message bus for other things in our network. So it's integrated. For the Elasticsearch part, most of it is sent into Docker. So it's pretty common tools, I guess, what we are using for this kind of integration. And then, other questions. Do you see any use case for this kind of updates with the BGP? Someone commenting on this?
Microphone, please.
Hello, hello. Microphone?
I'll show it. No, we need to broadcast.
Hello?
Hello. Yeah, it's
okay.
Could you say who you are?
Craig Gallen, OpenNMS.
Hello.
The work you're doing with the students in terms of correlation, how are they going about that? What are they trying to do in terms of correlation? How is that feeding back into what you're doing? A second related question, are you looking at spreading this out around more than just 1 or 2 points of presence, but actually across the networks in Europe as a way of monitoring what's going on from BGP perspective?
The second one I understand, the good question. The first one I didn't get it quite well.
The first one was just a bit more detail on the correlation work that's being done as a research project.
Okay, yeah.
Thank you.
Great. Yeah. Good questions. Well, we're a foundation. We're a community approach as a foundation, as the NB-IP for the ISPs. For this DDoS mitigation service we're doing, is the ultimate goal for us to get rid of DDoS attacks at all. Not to make money, because we're non-profit, so making money doesn't make a lot of sense. And to know who the attackers are, you need to have analysis on DDoS attacks, for instance. So we use universities and the academic world to get a theoretically approach of analyzing DDoS attacks. And that's this DDoS pattern recognition project we have. They are not using our BGP updates from our perspective. So I don't know if this is your questions, but they are getting the PCAPs from the DDoS attacks to analyze, anonymized of course. So they get information from our network for the real DDoS attacks that are going on, and they can do analysis on this. And what we try to achieve is based on DDoS patterns to see if these are known DDoS attacks, and just like we are used to do with viruses. We have a virus pattern, and antivirus software knows if I see this pattern, I have to block this. And that's not something we are doing with DDoS attacks. We look at the behavior of a DDoS attack and then say it should be an attack or not, but not from known information. And that's something we try to achieve with the universities. But then students come and go, so it's always taking a lot of time. And our main goal is to mitigate DDoS attacks, so this is side projects. That's the first question. Is this okay? Yeah. Second question was if we have other POPs where we get information from the public BGP, I guess. And not yet. We have our main infrastructure ourselves. There's where we get information from. We have up to 3 transits now with 3 or 4 IXs connected, and that's where we get the information from. So it's our view of the internet. Everybody has his own view of the internet, as you will, I think you will know this. So it's only one view, but it could be expanded, of course. And I think it's pretty easy to do. And maybe we can connect to RIPE or to the NL-NOC ring. I don't know if you have a ring like the NL-NOC. Do you know this? Do you know this NL-NOC ring? No.
Yes. We
Yes?
don't have one.
You don't have one.
No, we all use that one. We just use the Dutch one.
You use the Dutch one. Yeah. Great, of course. Why invent the same wheel again? So maybe, well, we'll have to talk to NL-NOC. Maybe this is something we can implement in the NL-NOC ring. I will see if this is possible. And that would be a pretty good view of what's going on, I think. Is this an answer? Great. Questions, remarks, comments? Does it make sense, or is it a very stupid idea? It could be possible. A stupid idea. I don't go on with developing on it. No one? Okay. Great. Thank you.
Thanks.
Oh, sorry. There's a question.
Yeah. Hi, Nick Hart from Lancaster University. I'm curious whether you have any concerns about performance in EXA, because EXA BGP is probably not the fastest BGP engine in the world. I'm just interested if you were getting like a full table dump. Our experience would be it would take quite a while to process that.
Yeah. Okay, question on performance. May I take it in general? Yeah. EXA BGP is not the very fastest implementation of BGP to begin with. Agree. But this is only a receiver from this perspective. It's not a sender for BGP updates. It's only a receiver. So I've done some measurement, no tuning at all, done nothing in a Docker, in a VM. So we begin with a VM on VMware. It's in a Docker and then implemented. The EXA BGP is keeping up with the full table. It's sending to the RabbitMQ. RabbitMQ with acknowledgements is capable in this setup of 3,000 messages per second. It's sent to Elasticsearch and the Kibana. That is way faster than the RabbitMQ in front of it. It can keep up with, I believe, 80,000 messages per second. Well, and with a 3,000 messages per second, it takes about 2 or 3 minutes to get the full table in. Well, it takes some time, but it's not that long. If you have the full table, it's only about updates on the full table. So it is, for the EXA BGP, it's only the 20 to 30 messages per second. And EXA BGP can keep up with this pretty well, no problem. If you ask, that's one of the messages on the bus. If you ask the bus, give me the full prefix list, then the RabbitMQ will send it. And that's a way faster implementation than the EXA BGP. Agree? Yeah. So what's implemented, not yet here, but it's in the infrastructure, in the idea it's implemented, to have some system receiving the BGP updates and keep track of it, and then you can ask the bus, give me the full prefix list. And this system will update it on the list. So it's not about EXA BGP then anymore. Yeah? Great. Other questions, comments? Good idea then, this? Okay, thank you.
Okay, thank you.
Okay, thank you.
Okay, thank you very much, Pim.